I am. I stopped in, usually the train stops either or Cape Verde.
Okay, so yesterday I guess we got through the section on sort of the LCD stuff. So before we look at 7.4 and adding and subtracting fractions, let me just see if you guys have questions like usual. So let me log in first. Well, I did get your assignments done too, so probably a little late, but I was entering those into the computer. So I do have your assignments that were treated last Friday done. Also, just to remind everybody about the final exam. Again, I looked online. This hasn't been posted yet, but I think I originally told you that the final, it looked like the final was going to be on Monday morning, but I think it's actually going to be Tuesday morning. So, so the final exam, again, which isn't for several weeks, but I'll probably write this on the board every day from now on until the end of the semester. The final exam is from 9:30 to 11:30, and that's on Tuesday, May 11th. So it's not Monday morning like I originally thought. So and that is in room 137A, which is this room. Okay, so and I'll give you guys more information about the final exam as we get closer to the date. But if anybody has any conflicts or anything, please make sure that you talk to me about that right away. And if you normally work at that time or something, I mean, hopefully that won't conflict too much with anybody's schedule. But if you normally work at that time or something, try to arrange your work schedule so that you aren't, so that you can try and be there for that. If you really can't do that, come and see me. Or if you have another conflict with the final, then remember we don't have normal classes during finals week. So if you normally have a class from after this one from 9:30 to 10:30 or something, that shouldn't be conflicting unless, for whatever reason, your instructor decides to meet that week, which normally they wouldn't. But so just remember that, again, that's when the final will be. Again, like I said, the official schedule isn't up online yet, but so I guess I'm not 100% sure if that's official, but I'm pretty sure that's when it will be. So it won't be Monday morning like that. So okay, so so before we do anything else. And then also maybe just remind everybody too is, remember there is a math club talk this Friday for those of you that might be interested in getting some extra credit. So I don't remember if anybody came to the last one, but it's at 3:30 on Friday, and that's in room 209, which is at the top of the escalator on the second floor. But if you do, they usually only last for like an hour. So from 3:30 to 4:30, and there's usually free pizza and soda afterwards, and they do give away gift cards or graphing calculators and things like that occasionally. So so if you're interested in that, plus you get to learn about some math that you might not normally get to hear about. I mean, a lot of people think that math is just algebra or whatever, and there's nothing more to it than that. But what you learn in your math classes is just the tip of the iceberg. So there's a lot of other interesting areas of math. And I think this talk is going to be about the relationship between math and art. So if you like art or something, this might be something that you might be interested in. Or if you like computer graphics and stuff like that, it might relate to that. So we're going to talk about projective geometry and stuff like that. So anyway, so that's this Friday. So for those of you looking for some extra credit, it won't be a whole lot, but what I'll probably do is just add 10% to the assignment you turn in this Friday. Okay, so before we do move on to the next section, did anybody have any questions about anything in 7? Sorry, in 7.3 or anything like that?
Yeah, can we go over 69 and 7.3?
7.3? Oh, okay, the last one. Okay, so the last one's all in the hard. So let's take a look at that one. So, okay, so for this one, you've got 2 over z minus y, and then that's over y squared plus yz plus y squared, and that's equal to y to the 4th minus zy. And they're kind of asking you, what do you need to figure, what does the numerator need to be in order for those two things to be? So the idea basically is, what you're doing in this case is you're taking this thing here, and you're multiplying on the bottom by something. And you're taking that thing on the bottom and multiplying it by something to get this thing on the bottom. So the hard part though is, what are they multiplying by to get that, which is the hard part. Now, one thing you could maybe consider doing is, and you could just think about, well, what would you multiply this by? But another way of thinking about it too is take this and try and factor it where that's maybe one of the factors. So if you can't figure out what to multiply by, try taking that apart. So the idea is, it might be hard to figure out what to multiply by, but maybe take this thing and factor it. So if you notice, there's a common factor of y, so you can pull that out. So that'll leave you with y cubed minus z cubed. Okay. So now the question is, can you factor y cubed minus z cubed? Yeah, that's a difference of cubes, right? So using our formula, that'll factor into a minus b times a squared plus a times b times b squared. Well, in this case, a and b are y and z, right? So it's just y minus z times y squared times yz or zy, whichever way you write it, and then z squared. So the idea is, if you look at that, that might give you an indication of what you're multiplying by here. So if you look at this, this is the same thing as that. I guess I've got the order written differently here, right? Over there it's yz, and here it's zy, but that doesn't matter, because it's the same thing. So the idea is, I've got this in the bottom over here, so what does it look like I'd want to multiply by to get that? Well, it looks like I'd want to multiply by y minus z, and then I'd also want to multiply it by a y. So if I multiply by y minus z and y, right, if I take that, times that, which is the same thing I have here, it should be equal to that. Okay, so the idea is that, well, that's what I have to multiply the bottom by, so to get that, I have to multiply this on the bottom by y minus z and y. Well, if I multiply the bottom of a fraction by something, remember to keep everything the same, I also have to multiply the top by the same thing. So the idea is that's what you want to multiply by the top, and I think they just leave it like that. You don't actually have to FOIL that out, but so it should be like something like that, or you could, you can move the y to the other side. You can rearrange the order any way you want here. So I don't know how they have it written, but so something like that, or some rearrangement of that. Again, you could have, you could have the y minus z first, and the z, minus y first, or something like that. But, so yeah, so I think that is kind of an nasty one. I don't think it's nearly as easy as some of the ones we did yesterday, where you could just kind of look at it, right? But it's a sort of a trick or a way to turn things around. If you can't figure out, what to multiply by to get that, think about taking this and factoring it, and then one of your factors should be the thing in the denominator. So yeah, so I think that one's kind of tricky. I mean, when I first looked at that one too, I'm like, boy, what am I going to do with this one? So
I was feeling lazy about this.
Oh, that's okay. That's a hard one. So okay. So anybody else have questions about that? Yeah. So these problems aren't always easy, especially the ones for the end. I doubt you'll see one like that in the exam, but it's still the same idea. You're sort of trying to figure out, what am I multiplying by in the bottom to get that? Once you figure that out, you just multiply the top by that, and that'll give you the answer. So the answer is just the top. I think when they actually write the answer down, they actually write the whole fraction down. So they will, like if you look at the answer for this one, they say the answer is 2y times z minus y times y minus z. And then, so I guess it depends on what you're looking for, I guess. If you're just looking for the question mark, I guess it's just the top of the fraction, but they include both of those. So on the exam, what I'll probably do is just have you figure out the numerator, unless they have to write them down. Okay, so any questions about anything else from the first couple sections of chapter 7? Everybody else is okay? Okay, well if everybody's okay, let's go ahead and move on to the next section. So just double check stuff just to make sure you guys don't have any questions before we move on here. Like I said, just keep, if you forget where the final is or when the final is, like I said, that will be, that should be posted online eventually, and all your other finals also should pretty much be posted up there unless they're, unless one of your classes are, doing them last day of class or something like that. But, and again, I'll give you more information about the final as we get closer to the end of the semester, so don't, I know you guys might be starting to worry about it now, but it's at least a couple weeks away, so don't start worrying about that yet. Well, I'll give you some more information, but just remember that the final is 2 hours long. It's not an hour like the usual exams, so keep that in mind. But if you do want to find out where the final is, again, just go under the alphabetical index on the home page and go under E for exam, and like I said, so like I said, right now they don't have the spring schedule posted up there yet. It's still waiting. Or you can also go under F for final, and it should indicate at least once they've posted it, it should indicate when and where the final is. So if you can't remember, like boy, was my final on Monday or Tuesday? It's Monday morning and you can't remember. You should be able to look online because it should be posted by then. You can always email me too if you want. Okay, so let's take a look at the next section. So we looked at how to find the common denominator. So now what we're going to look at in this section finally is actually how to add and subtract fractions. But we've kind of done the hard part. The hard part, I think, when you're adding and subtracting fractions is to find the common denominator. So the basic idea, just to remind everybody, is once you've got the common denominator, right, then you just add the numerators together. Or if you're subtracting, you just subtract the numerators. So remember, the idea is if you have 2 plus 5 over 3 plus 5, it's just 2 plus 3 over 5. Remember, you don't add the 5s on the bottom together. You just write that common denominator down, right? So it's kind of like saying that you have 2 out of 5 pieces of cake, and if you add 3 out of 5 pieces of cake to that, you'll have 5 out of 5 pieces, or 1 whole cake. Right? That's sort of the idea. Right? Same thing here. If you have 3 out of 5 pieces of cake, you've eaten 2 already, and then you eat 2 more, and that'll give you 1 out of 5 pieces. That's sort of the idea. So the trick is to try and get the denominators to be the same. Once you do that, then you just add or subtract the numerators. So let's look at some examples here. And then also just remind everybody too, don't forget to reduce, like the 5 over 5, you can reduce that to 1. So sometimes you can reduce and sometimes you can't. So like for example, let's just do something where we already have a common denominator. So like this one, I've got 3 over a plus 1 over a, right? That would just be 4 over a. You can't really reduce that. Or if you have x over x plus 1 plus 3 over x plus 1, right? That's just x plus 3 over the common denominator of x plus 1. And then just be careful here, right? You cannot reduce the x's, right? Because you're adding and subtracting. If it was x times 3 and x times 1, then you can cancel. But because you're adding or subtracting, you can't cancel. So like the one on the bottom, let me maybe do the one on the bottom on the board because that's kind of a long one. So the one on the bottom, you've got 5x minus 1 over x squared plus 2x plus 1. And you've got 4x minus 2 all over x squared plus 2x plus 1. So again, you've got a common denominator of x squared plus 2x plus 1. So just take the tops and subtract it. So you take 5x minus 1, and then just be careful here, right? Remember, this subtraction sign applies to both 4x and the negative 2, not just 4x. So that'll give you minus 4x. And then if you subtract the negative 2, remember that's the same thing as adding a 2. Right? And then that'll be all over the common denominator of x squared plus 2x plus 1. And then just simplify the top, right? 5x minus 4x, that'll give you x. And then negative 1 plus 2, that'll give you plus 1. And that's all over x squared plus 2x plus 1. Now you might think that's all you have to do. And then basically it is, but remember, don't forget to reduce. And you might think there's no way to reduce that, but if you look at the bottom, it's factorable. So you can actually factor the bottom. The bottom is x plus 1 squared, right? So that's just x plus 1 times x plus 1, right? Because 1 times 1 is 1, and 1 plus 1 is 2. So now that you've done that, now you can actually cancel the x plus 1 on top with one of the other x plus 1s, and that'll leave you with 1 over x plus 1. And that'll be the final answer. So again, don't forget to reduce. If you, like for this one, if you just left your answer like that, I could probably give you full credit, but it might take a couple points off because you don't reduce. So when you add and subtract fractions, don't forget to reduce your answer when you're done. Okay, so those are pretty easy though, right? Because we've already got a common denominator. So the question is, well, what happens if you have a different denominator? So we kind of did the hard part of that yesterday. So before we talk about that, any other questions about those? Again, just remember when you're adding and subtracting fractions, right, you just add the tops together, you don't add the denominators together, right? You just write it as a common denominator. Okay, so again, well, what happens if the denominators are different, right? What if they're not both the same? Well, then that's kind of what we did yesterday, right? The hard part is to find the LCD, that's what we did yesterday. And the idea then is you have to change each fraction sort of to higher terms with the LCD and the denominator. So what that means basically is what we were just doing in that question, what was it, 69 on the board. Right? If you've got a common denominator, remember you may have to multiply the top and bottom by something to change the fraction into something that means the same thing, but with the LCD as the denominator. And then you combine. And the reason why I'm saying combine is because in some cases you may be adding, in other cases you may be subtracting. So combine just means add or subtract. And then don't forget to reduce. So again, it's a lot like if you were to add or subtract, like 1/12 and say 1/18, right? Like what would the LCD be there? What, 36, I think, right? So the idea is, what would I have to multiply the top and the bottom by there to change the 12 to 36? Yeah, I need to multiply the bottom by 3, so then keep the fraction the same, I need to multiply the top by 3. What would I need to multiply the top and the bottom by here? 2. So I need to get 36 in the denominator, so I'd get 3 over 36 plus 2 over 36. So that'll give you 5 over 36. Right? So it's the exact same procedure as this. You divide the LCD, which in this case is 36. And again, that's easier said than done. Again, if you didn't see that, you can factor 12 into 2 times 2 times 3, and 18 into 3 times 3 times 2. So the LCD would be 3 times 3 times 2 times 2, which would be 36. So that can be kind of the hard part. And then the idea is, so that's step 1. And step 2 is to change each fraction to a fraction with the LCD. So that's what I mean when I say build each fraction to higher terms, meaning that the terms on top are bigger. With the LCD and the denominator, then just add the numerators, combine the numerators in this case, and then 5 over 36, you can't reduce that, right? Because 5 doesn't go into 36, right? 36 and 5 don't have factors in common. So that's the procedure, right? So I mean, exactly the same thing you did when you were younger. Again, the only hard part is, again, now we're going to do it with stuff with x's in there. So I think the hard part will be sort of finding the LCD. Once you've done that, right, then it's just kind of back to what we did before. So let's look at some examples. So let's say that you have 5 x over x plus 2, and you've got 10 over x plus 2. So the first thing to do there is to find the LCD. So what would the LCD be there? Yeah, I've already got the common denominator, right? So I guess in a way I'm maybe sort of tricking you by making that more simple than maybe you're expecting. Right? The idea in this case is you've already got a common denominator, right? So what do you do? Yeah, you just take the top, just take the top and add them together. So just going back to the procedure, you find the LCD, right, and then change each fraction into something with the LCD in the denominator. Well, we don't really have to do step 1 and step 2 because you've already got a common denominator, right? And then just add them together, and then is that it? Yeah, if you look at it, there's actually one more step there. Yeah, so that one you can reduce. So if you look at the top, you can pull out a 5. That'll leave you with x plus 2. And then we go get an x plus 2 in the bottom, and then that'll reduce. So the idea is that's actually 5. So don't forget that last step, simplifying. Remember, in some cases you can reduce it. Right, but you can see it's pretty much the same thing here, I guess, except this one's a little bit easier because we didn't really have to find the LCD. So let's do one where we have to find the the LCD. So let's take a look at the next one. So the next one, we've got 5x squared y plus 2 over xy. Okay, so what would you do for that one? I mean, the first step is to do what? Yeah, so to find the LCD, right? So take the denominators and factor them. So like this one, you can maybe just see what the LCD is. So maybe just before we actually find it though, can anybody see what the LCD is going to be for that one? What's that? Yeah, right. So the LCD I think is going to be 5x squared y. Right. Again, if you don't see it though, let's actually go through the procedure. Let's go through what we did yesterday. So remember, to find the LCD. Again, if you see it, that's great. But if you don't, let me just go over it again. Find the LCD. You take each denominator and factor it. So 5x squared y can be written as that. And then the denominator here, if you factor that, that's just going to be xy. So how many 5s will your LCD contain? Yeah, just 1. And then how many x's? 2, right? So remember, it won't contain 3, it'll just contain 2, because that has more, and so you only pick the one that has more. And then how many y's?
1.
Yeah, just 1. So in other words, if you look at this, right, that's already the LCD, right? So whoever said, don't you just multiply by 5x? Yeah, that's right, because you just multiply on the bottom here by 5x to get that, right? So the idea is multiply on the bottom here by 5x will give you 5x squared y, right, which is what the LCD is. But then what else do you have to do? Yeah, remember you have to do it, at the top, right? So whatever you do to the bottom of a fraction, right, if you multiply the bottom of a fraction by something, do it to the top. So that'll give you 6 over 5x squared y plus, I guess, 10x over 5x squared y if you were to multiply out the bottom. Right, and now you've got the same denominator, so just add the numerators, right? So that'll give you 6 plus 10x over 5x squared y. And then the only other thing is just to check and see if you can reduce. So can you reduce that one? Don't think so, right? I mean, in order for 5 to reduce, 5 would have to go into both 10 and 6, so you can't reduce that. Again, that x will not cancel with that, right, because you're adding in there. Right, there'd have to be an x in each term in order to cancel. So that's all the further you can go with that one. But you can see that the procedure here is almost identical to what we did here. Right, you first of all find the LCD, then you just multiply the top and bottom of your fraction to get the LCD in the denominator. Now this one's a little bit different because we didn't really have to do anything to this fraction because it already had the LCD. But then once you do that, you just add the numerators together and then just check to see if you can reduce, right? And just like this one, that one doesn't reduce. So we're basically going to use the same 4-step procedure for all of these problems, right? So just find the LCD, change both fractions to something with the LCD in the denominator, add or subtract the numerators, and then just simplify. Okay, so let's do some more examples here. Let's take a look at the next one. Were there any questions about those so far? Are you okay? Okay, so let's take a look at the next one. So let's say you have 2 over x minus 1. You've got minus x over x plus 2. Okay, so again, the hard part I think is finding the LCD. So what would the LCD be for this one? This one might be a little tricky. If you think about it, it's not too bad. I mean, what are the only factors you have? Yeah, you have x minus 1 and x plus 2. What's the largest number of times those occur in either denominator?
1.
Yeah, once, right? So the LCD would be what? Yeah, x minus 1 times x plus 2, or or you can switch the order, right? X plus 2 times x minus 1. So the idea then is, well, what do I need to multiply by then here in the next step? So like the fraction on the left, what would I need to multiply the bottom by here to get the LCD? Yeah, x plus 2. So the idea is just look and see what's missing. All right, I've got an x plus 2 missing. So again, just remember, whatever you do to the top, you have to do to the bottom. Whatever you do to the bottom, you have to do to the top. And then what would I want to multiply the top and the bottom by here? Yeah, x minus 1. And then just to clarify here, right, you're not just multiplying it times the 2, so let me put that in parentheses. right? Then just FOIL out the top, so or just distribute, right? You get 2 times x and 2 times 2. So the top there will be x plus 4. And then just be careful with this one, right? Because I've got a minus, and that applies to everything. So there are a couple ways you can do this. Let me distribute the x through first, and then we'll take the negative and put that through. So I'll get x times x, which is x squared. And I'll get x times negative 1, which is negative x. But then I've still got that negative out in front, right? And then again, these are both over the common denominator. You know, you can skip steps here if you want.
The first one should be 2x.
Yeah.
Oh, is it? Oh, oops, yep, you're right. Forgot. Yep, you're right. Thanks for catching that. Anybody else have questions? You know, notice anything else? What's that? Oh, oops. Oh, yep. Sorry. Okay. That look okay? Okay. And then just distribute the negative, right? So then you'll get 2x plus 4 times minus x squared plus x. And then that'll be all over your common denominator. And then I guess normally you'd want to, write things, simplify things if you can. So I guess, try to write the thing on the top so that the powers go from highest to lowest. So you get negative x squared, and then plus 3x, and then plus 4 all over that. So just move the negative 2x squared to the front, and then take 2x plus x, that's 3x, and then you got plus 4. And then is there anything else I can maybe do? Or is that it? Yeah, you can maybe reduce. Yeah, I don't know if you can factor that or not, but let's take a look at it and see if you can. So I guess just to make this easier to factor, let's pull a negative 1 out of the top. Maybe you can factor that. So can you factor that? It's what, minus 4 and plus 1. Now, unfortunately, though, is that going to cancel anything? So you're right, you can factor it. And so the top will factor into that. But is that going to cancel with anything on the bottom?
If you bring the negative through.
Well, careful though, right? Because if you bring the negative through, that will make that negative and that negative. So if you brought that through, right, you get negative there and negative there. So it's still almost canceled, but not quite. And yeah, so it seems like that might work. But yeah, unfortunately, these almost cancel, but not quite. So the idea is, if it doesn't reduce, you could just leave your answer in this form. But I'm never sure until I factored things. Because if you look at it, I mean, it looks like that. Up here, it looks like you can maybe get a -1 and get stuff to cancel. So just be careful though, right? Just because it factors doesn't mean it's going to cancel the stuff on the bottom. So like you could have just left your answer like that if you wanted to. If you want to write it that way too, that's fine. So if it doesn't reduce, you don't necessarily have to factor. But how do you know whether things are going to cancel until you factor? Well, you don't. So whichever way you want to write it is fine. And if you factor it like this and it doesn't work out, you can just leave it like that. So you should have that answer there already. I'll just take that. But factor just to be sure, right? I mean, there's no guarantee that anything's going to cancel there, but it might. So just be careful. Again, the idea is the procedure for this one is identical to what we did here, right? You just find the LCD, multiply the top and the bottom by whatever you need to get the LCD. In this case, we're subtracting the numerators, and then just try to reduce it. Okay, so okay, let's do a couple more. Unless were there any questions about that one? I know that one was kind of tricky. You okay with that? Okay, let's take a look at the next one. So the next one I've got x over x squared minus x minus 6 plus x minus 1 all over x minus 3. Okay, so the first step, just like this one, is to find the LCD. And again, you might be able to just see it. And again, if you don't, then we have to go through the procedure. So does anybody see what the LCD is going to be there? Yeah, it's going to be x squared minus x minus 6. How did you know that?
You take the x minus 3 times x.
So that one can factor, right? So if you take the the x squared minus x minus 6, that factors into x minus 3x plus 2. And then x minus 3, if you factor that, well, that doesn't really factor, right? That factors into x minus 3. So the largest number of times you see x minus 3 appearing is how much in each factor. Yeah, so it appears 2 overall, but in each factor, right, it appears there and it appears there once. So you'll have 1x minus 3, and then are there any other factors? Yeah, x plus 2, and there's only one of them, right? There's 1 up there and 0 down there. So the largest number of times it occurs is 1. So, and if you FOIL that out, it gives you that. So the idea is this already has the LCD. So we don't really have to do anything with that. Maybe just to make things easier, let's actually factor it though. Right, so that'll factor into that. And then I'll get this over here. So what do I need to do to this one to get the LCD? What do I have to multiply the top and the bottom? Yeah, so I've got an x plus 2 missing, so to get the LCD I need to multiply by x plus 2, right? Because the LCD is x minus 3 times x plus 2. And whatever I do to the bottom, I do to the top. Okay. I'm going to skip a step here, right? So you'll notice that eventually, you're going to combine everything over the same denominator anyway. So rather than FOILing stuff out, let's just go ahead and put everything over the denominator here. And then we'll just kind of work the top out, right? So the idea is, I could FOIL this out and put it over the same denominator, but again, you're going to combine them together anyway. So you'll get x here, and then if you FOIL this out, you'll get x squared, and then you'll get plus 2x minus x, so it'll give you plus x, and then you'll get minus 2 from that. So if you FOIL that out, you'll get x squared plus x, and then minus 2. Okay, and then the idea then is then you can combine the x's on top, I guess. So if you do that, you'll get, I guess what, x squared plus 2x minus 2. And so that'll give you that. Okay, so anybody have any questions about that so far? Okay, so is there anything else I can do maybe? Because you could try and reduce. Can you reduce that one? I don't even know if you can factor the top. Can you factor the top even? No, I don't think so, right? Because you'd have to find numbers you can multiply together to get negative 2 and add together to give you 2. So I guess you could try it. If you factor the top, it'd have to be like x and x. And then it would have to be like negative 2 and plus 1 or something. But negative 2 plus 1 doesn't add together to give you 2. Even if you switch the signs around, right, that still wouldn't work. So it looks like the top, you can't even factor the top for that one. So there's no way that that's going to reduce, right? So that's all you can do for that. But always check. Don't forget to, don't forget that last step. It's kind of one of those easy things. So don't forget to check and see if that can use. Okay, so let's take a look at a couple of other examples here, and then they'll finish things off. So let's take a look at the last one here. So the last one I've got x minus 3, and then I've got x squared plus 2x plus 1, and then I've got that. So what would I want to do first for this one? Yeah, good. So I threw this one in here to kind of keep you guys on your toes, right? What are we talking about in this section? Yeah, we're talking about adding and subtracting fractions. So if you look at that one, in fact, those of you on the other side of the room, if you look at it, you may think that that's an addition sign, right? But it's actually division. So be careful. They may throw like a problem from the previous section in here just to keep you on your toes. So what would I want to do first for that one? And I guess I want to flip it over. And then what do I have to do? Then I have to find the LCD, right? I've got it flipped over, then I have to find the LCD for those two things, right? Well, when you're multiplying, you need to find the LCD? No, right? Only when you're adding and subtracting. Yeah, so the idea is you want to factor stuff and cancel, but the important thing to realize is, remember, when you're multiplying and dividing, you do not need to find the LCD, right? So just be careful. This is actually from the previous section, or section 7.2. Right? So the idea in this case is that you want to factor everything and then just reduce. You want to factor right into x minus 3x plus 3. And then what about the top here? Yeah, so x plus 3x plus 1. And then this is just x plus 1 squared, so that'll just be x plus 1 times x plus 1. Here you have a difference of squares, right? So that'll be x minus 3x plus 3. So I think that's back. So is everybody okay with that? Okay, then just start reducing, right? So x minus 3 will cancel with x minus 3. X plus 3 will cancel with x plus 3. One of these x plus 1s will cancel with one of those. So what's the numerator going to be?
1 over x.
Yeah, so it'll be just 1 over x plus 1. So mainly the reason why I put this one in here is to just make you guys pay attention, right? Don't just assume when you're doing the homework that they're always going to give you addition or subtraction, or like on the exam I might give you a bunch of problems where you're doing addition and subtraction and then throw a division one in there. So just make sure you pay attention to the sign. What if I did ask you to add these together? So let's say, just to make this easier, let me write it in factored form. So let's say that was a plus sign. Actually, we can probably make this one a little bit easier. Let me actually factor the top here. So one thing you could do to actually make this one a little bit easier is if you factor the top, that'll factor with a factor of x plus 3 in there, and so this will actually reduce with that. So to make this a little bit easier, you can actually reduce the fractions before you add them together. So that we do that. So that might make the LCD a little bit easier to find. Okay, so you got that. So then look at the denominators. What's the LCD going to be there? Yeah, x plus 1 squared, right? So the only factor you have is x plus 1. Again, look and see how many times it appears in each denominator, right? It appears here twice and there once. So the LCD will be whichever one has more x plus 1s, right? Or the product of those, and the only thing you got is x plus 1. So the idea is, right, it should just be x plus 1 squared. So the idea is you've already got the LCD here. What do I have to do to get the LCD here? Yeah, just multiply the top and bottom by x plus 1. So now again, I can just kind of combine these together because they're already over the same denominator. My advice to you would just be to leave the bottom factored until you're done, because again, stuff might cancel. So don't FOIL stuff out and write that back as x squared. X squared plus 2x plus 1. Just leave it like that. And then the top is going to be x minus 3. And then it'll be plus whatever you get when you FOIL this out, right? So it'll be x squared, and then you'll get what? X minus 3x, so that'll give you minus 2x. And then you get minus 3 times 1, which is minus 3. And then all you need to do is combine my terms on the top. So if you do that, let's see, on the bottom you'll still have the same common denominator. Right, and then on the top, let's see, you'll get what? X squared. So let's see, x minus 2x, what's that? That's minus x. And then you'll get what? Minus 6. Alright, so minus 2 minus 3. Okay, then the only thing is, I guess, is can you reduce that?
Yes.
Right, I think you can factor the top, whether it'll cancel with anything in the bottom, I don't know. But the top, I guess, will factor into what? X minus 3 and x plus 2. Unfortunately, though, that doesn't contain an x plus 1, so it's not going to cancel with anything in the bottom. But it's always a good idea to factor and check just to be sure. So if you really want to just leave your answer like that, that's fine. But I think it's always good to factor just to double check. I mean, it may not look like there's a factor of x plus 1. Once you actually factor it, it may look like it's going to cancel. So that's all the further you can go with that. So the idea is, again, just make sure that you pay attention to the operation, right? If it's, remember, it's division or multiplication or something like this, right? If it's division, you just flip it upside down, factor and cancel. You don't need to find the LCD, but if it's addition or subtraction, that's when you need to find the LCD. Okay, so is everybody okay with that? Okay. So much time we have left here. Okay, so I think that's pretty much it for that section. Let me maybe just do it, maybe pick a couple more examples out of that section to do, and then we'll take a quick preview of the next section since we've only got like 5 minutes left. But let me maybe just pick one more. Let me try and pick a hard one. Let's do 40. Let's do 48. I don't know if that's a hard one or not. So 48, I guess one thing that makes that one difficult is that you've got more than two fractions you're adding together. So you've got 2p over p minus 3, and then 2 plus p over p, and then minus a negative 6 over p squared minus 3p. So let's take a look at that. So the idea in this case, again, is you just want to add and subtract those, right? So the first thing you want to do then is to find what? Yeah, the LCD, right? So now, again, that can be kind of difficult. Again, can anybody look at that one and see what the LCD is going to be? This one's tricky. I don't know if you'll be able to do it. I'm not sure if I can see. What is it?
P times P minus 3.
Close, I think. Yeah, well, yeah, I guess that would be, you mean times p minus 3 in parentheses, right? Yeah, so I think that's right. So again, if you don't see it, again, how would you find the LCD if you didn't see that? You would first of all take each denominator and factor it. So just to make things easier, let's instead of factoring it over here, let me just factor them actually over here. Right, so the idea is that's not going to factor, but that will factor into p times p minus 3. So if you look at it, right, the largest number of times that p occurs in any one denominator is once, and the largest number of times that p minus 3 occurs in any one denominator is once. And you might think, well, if I have p minus 3, doesn't that take care of the p already? Well, you think about it this way, right? Well, like what if p was 8, right? If p was 8, you'd be saying that 8 and then 8 minus 5, right, so or 8 minus 3, right, you'd be saying that 8 goes into 5, but it doesn't, right? So remember, p and p minus 3 are two completely different numbers. So just because I've got the p in there does not mean that if you write down p minus 3 that it takes care of that p. So that would be the LCD. So then what do I need to do to change each denominator to the LCD? Like here I need to multiply the top and the bottom by what? P. Here I need to multiply the top and the bottom by what? Yeah, p minus 3. It is right. It is 2 plus p, isn't it? Yeah, I guess that's right. Okay, and then just again, put all that stuff together over the common denominator, right? Because when you add it together, you're just going to put it over the common denominator anyway. And just work out the top, right? So that'll be 2p squared. And then here you have to FOIL that out. Now this is going to be kind of tricky because this is kind of backwards from the way you would normally do it. So just to make things easier, let's just rewrite that as p plus 2. Right? Because p plus 2 is the same thing as 2 plus p. And then FOIL that out. So you'll get p squared. And then you'll get negative 3p from that, plus 2p from that. So it'll give you negative p. And then you'll get 2 times minus 3, which is minus 6. And then here, just be careful, right? You've already got the common denominator there, so you don't need to add and subtract anything on the top. But you're subtracting negative 6, so that'll give you a plus 6. Then just combine like terms together on the top. Looks like the 6's will cancel there. So you'll just get 3p squared, right? So 2p plus p squared, and then minus p. And that'll be all over p times p minus 3. And again, don't FOIL this out. Don't distribute the p through until you're done. So that gives you that. So I guess, can I reduce that? I think so, because I can at least pull a common factor of p out of the top. So the top I can write as p times 3p minus 1 over p times p minus 3. And then I can cancel the p's. So it'll give me 3p minus 1 all over p minus 3. And then again, just remember that you cannot cancel the p's there or the 3's, right, because you're adding and subtracting. Okay, so I know that one was kind of tricky. So any questions about that one? I know we don't have a whole lot of time. Okay, so before you guys go, let me just quickly talk about what we're going to look at tomorrow. So tomorrow what we'll look at is we'll look at complex fractions. And those are sort of fractions within fractions, where you have like, say, maybe 1/2 plus 3/4, and then that's divided by like, say, 1 minus 1/2. And you guys have probably done those before, but maybe it's been a while since you've done them. If you think about it, it's really the same thing that we did today, you just have to sort of do it twice. You'll see that there are two methods for handling this. Okay, so we'll look at that tomorrow. Oh, and I should put the assignment up here too. So the assignment is 1 through 75 up. Oh, that's right. Yeah, you were gonna. Yeah, when did you? Okay. And is there a reason what you do? Oh, that's right. Yeah. You emailed me. Okay. So, can you? Let's see. What are you gonna do today? Okay. Do you want to do it right now? Yeah, you can do it right now. Yeah. Do you want to just do it now? Yeah. Okay. Yeah, is that what we talked about yesterday? I guess I don't. Yeah, we can just do it right now. You wanna just hang on? Actually, do you know where my office is?
No.
Okay, why don't you just hang on and we'll go through it. You don't have like another class right now. Wait. Just cut out.
Are you teaching the next level in the fall?
I'm teaching at the summer. Wait, no. Oh, yeah, I'm not. I'm teaching 2 more sections of this. Oh, I should grab the camera now. I should. Yeah, I'm teaching 2 sections of this online, and then